The rain taps against the floor-to-ceiling windows of our downtown Seattle office as I settle into my standing desk on the 15th floor. Steam rises from my matcha latte, a ritual that's marked the start of my workday for the past 4 years. The open-plan office buzzes with the familiar symphony of mechanical keyboards and hushed conversations about sprint planning and deployment schedules. I'd love to know which corner of the globe you're watching from. And if this story speaks to you, make sure to subscribe. Tomorrow's video is one you absolutely can't miss. I pull up my terminal, fingers dancing across keys worn smooth by countless hours of coding. The codebase loads, 178,000 lines of Python, JavaScript, and SQL that I've crafted, debugged, and refined into something beautiful, something that works flawlessly, day after day, processing millions of dollars in financial transactions for our fintech startup, Meridian Pay. Most people see code as just text on a screen. I see architecture. I see the elegant flow of data through carefully constructed pipelines, the graceful handling of edge cases that would crash lesser systems, the security layers that protect our clients' most sensitive information. This isn't just software. It's a $12 million revenue engine that I built from scratch when we were just 8 people in a cramped co-working space. My phone buzzes. A Slack notification from Jake, our CEO. Maya, the new VP of engineering, starts today. Can you give her a walkthrough of the core system? She'll be your new manager. I glance across the office to see a woman in an expensive navy blazer talking animatedly with HR. Her laptop case bears the Apple logo and a collection of startup conference stickers. LinkedIn probably calls her a seasoned engineering leader and lists her experience at 3 different companies in the past 5 years. The type who speaks fluently about scalability and technical debt, but hasn't written production code since boot camp. Her name is Victoria Chen, and her resume reads like a Silicon Valley bingo card. Stanford MBA, previous roles at 2 unicorn startups, expertise in transforming engineering culture and driving operational excellence. What it doesn't mention is that both companies she left were later sold for parts after their systems mysteriously started failing. By noon, Victoria has commandeered the largest conference room for what she calls a technical architecture deep dive. The entire engineering team crowds around the glass table while she connects her MacBook to the wall-mounted display. Her presentation opens with the title, Modernizing Our Legacy Infrastructure. Legacy. The word hits like a slap. My system isn't legacy. It's battle-tested, optimized, and generating consistent profits. But Victoria doesn't pause for questions. She clicks through slides filled with buzzwords, microservices, containerization, cloud-native architecture, diagrams with too many arrows and not enough substance. As we can see, Victoria says, gesturing to a slide titled, Current Technical Debt Assessment, our monolithic structure presents significant scalability challenges. We need to decompose this into modern, maintainable services. I lean forward. The current system handles peak loads of 50,000 transactions per minute with 99.97% uptime. What specific scalability issues are you seeing? Victoria's smile doesn't reach her eyes. Maya, I appreciate the historical context, but we need to think bigger. Our investors expect exponential growth, not incremental improvements to amateur hour code. The room goes silent. Amateur hour code. The phrase echoes in my head as heat rises to my cheeks. Around the table, my colleagues, developers who've worked alongside me, who've seen me fix their bugs at 2 a.m. and architect solutions they couldn't imagine, avoid eye contact. I'd be happy to walk you through the architecture decisions, I offer, keeping my voice steady. The system might look complex from the outside, but each component serves a specific... That's exactly the problem. Overly complex. Tightly coupled, impossible to maintain. We need clean, modern code that follows industry best practices. Clean, modern, best practices. The holy trinity of managers who confuse shiny with functional. I've seen their clean code, pretty to look at, devastating in production. I've debugged their modern architectures that crumble under real-world loads. I've watched their best practices create more problems than they solve. But I don't say any of this. Instead, I open my laptop and pull up the monitoring dashboard. Green across the board. 0 errors in the past 48 hours. Transaction processing time averaging 23 milliseconds. The system purrs like a well-tuned engine. The metrics suggest the current implementation is performing well, I say. Victoria glances at the screen dismissively. Metrics can be misleading. We need to prioritize developer velocity and code maintainability over short-term performance optimizations. Developer velocity, the sacred cow of engineering managers who've never had to debug a distributed system failure at 3 a.m. while angry customers flood the support channels. I close my laptop and lean back in my chair. Around the table, the other developers nod along with Victoria's presentation, either convinced by her confidence or afraid to challenge someone with her credentials.
The meeting ends with Victoria assigning everyone to research modern alternatives to our current tech stack. She singles me out as we file out of the conference room. Maya, I'd like to set up regular one-on-one sessions to help bring your technical skills up to current industry standards. I think you have potential, but we need to modernize your approach. Potential. As if 4 years of building a system that's never failed, never been hacked, and never lost a cent of customer money is just unrealized potential. As if the late nights spent optimizing database queries and the weekends spent implementing security patches were practice rounds.
Dylan scrolls through the code with visible disdain. That's what monitoring and alerting are for. You don't need to anticipate every possible failure. I think about the night I spent tracing a seemingly impossible data corruption bug that only occurred when the system was under heavy load during Pacific Standard Time while the database was performing scheduled maintenance. The night I discovered that a specific sequence of API calls could create a race condition that corrupted financial records. The night I wrote the over-engineered error handling that Marcus wants to remove. But explaining this would require explaining the history they weren't there to witness, the crises they didn't solve, the disasters they didn't prevent. So I say nothing and watch them schedule the over-engineered code for removal in the next sprint. Victoria, meanwhile, focuses her attention on what she calls team dynamics optimization. She institutes daily stand-ups that stretch into hour-long discussions about velocity metrics and story point estimations. She introduces new project management tools that require us to log our time in 15-minute increments and categorize every task by business value impact. Maya, she says during one of our one-on-ones, I've noticed you're not embracing the new development methodologies. Your story completion rate is below team average, and your code reviews tend to be unnecessarily detailed. She's referring to my habit of actually testing the code I review, of running it against edge cases, of checking that the new implementations can handle the loads our system regularly processes. Marcus and Dylan approve each other's pull requests with lightning speed, barely glancing at the actual changes. I prefer to be thorough. Thoroughness is good, but we need to balance it with agility. Perfect is the enemy of good, and we're moving too slowly to market with these lengthy review cycles. She slides a printed document across the table. Performance Improvement Plan, the header reads. Below it, a list of objectives. Increase story completion velocity by 40%. Reduce code review cycle time. Demonstrate adoption of modern development methodologies. A PIP, the corporate equivalent of a terminal diagnosis. I scan the requirements, each one designed to force me into their way of working or provide grounds for termination. I fold the document and slide it into my laptop bag. I'll need some time to review this. Of course, we want to see you succeed, Maya. You just need to adapt to how successful engineering teams operate in 2024. That night, I open the Phoenix repository and begin documenting everything. Not just the code, but the reasons behind the code. The business logic that emerged from countless customer support calls. The security measures born from actual attack attempts. The performance optimizations that resulted from real bottlenecks under real loads. I also begin documenting something else. The changes Marcus and Dylan are making. The error handling they're removing. The security checks they're bypassing in the name of streamlining. The database optimizations they're undoing because they don't understand why they were there in the first place. Each commit to Phoenix carries a timestamp and a description, a forensic record of a system being systematically dismantled by people who mistake complexity for confusion, who confuse robustness with redundancy. 2 months after Victoria's arrival, the first cracks appear. A brief service disruption during peak trading hours when one of Dylan's simplified API endpoints fails to handle a routine database timeout. The system recovers automatically, my error handling is still mostly intact, but the incident triggers a flurry of concerned emails from our banking partners. Marcus fixes the issue by adding back some of the error handling he'd previously removed, but he frames it as implementing more robust exception management, rather than acknowledging that the original code was correct. The second crack comes a week later. A performance regression that causes transaction processing times to spike during high load periods. I trace it to a database query optimization that Dylan had modernized by removing what he called unnecessary indexing overhead. The indexes I'd carefully tuned were handling a specific query pattern that only emerged under heavy concurrent load, something their development environment never tested. Again, the fix involves quietly reverting Dylan's changes while he presents the solution as implementing advanced database performance tuning.
I document each incident in Phoenix, cross-referencing them with the original code that had prevented these exact problems. A pattern emerges. Every failure corresponds to a piece of amateur-hour code that had been removed or simplified. The third crack is different, more serious. A security vulnerability that allows authenticated users to access transaction data from other accounts, not through any sophisticated exploit, but through a simple API parameter manipulation that Marcus's refactored authentication system fails to catch. I discovered it during my routine security testing, a practice Victoria has criticized as outside the scope of individual contributor responsibilities. The vulnerability exists because Marcus removed what he called paranoid input validation from the user authentication flow. I immediately file a critical security report, but the response reveals how much has changed. Instead of the emergency response such issues once triggered, I receive a scheduled meeting invitation for the following week to discuss the security concerns with the architecture team. When the meeting finally happens, Marcus and Dylan listen to my explanation with the patience of adults indulging a child's monster under the bed story. They nod politely while I demonstrate the vulnerability, taking notes in a shared document titled Maya's Security Feedback. "Thanks for bringing this to our attention," Victoria says when I finish. "We'll add a story to the backlog to investigate these edge cases. Marcus, can you prioritize this for next quarter's security hardening sprint?" Next quarter, for a vulnerability that could expose every customer's financial data. I screenshot the security report, the vulnerability demonstration, and the meeting notes where it's dismissed as a low-priority edge case. Another commit to Phoenix. Security vulnerability reported. Meeting notes attached. Resolution scheduled for next quarter. That evening, I sit in my apartment with my laptop open to a job search site. Senior software engineer positions at companies that might value experience over buzzwords. But as I scroll through listings filled with requirements for modern cloud-native microservices experience and proven ability to build scalable distributed systems, I realize something troubling. The industry has moved on, not necessarily to better practices, but to shinier ones. Companies want engineers who can talk about Kubernetes and serverless architectures, not engineers who can build systems that actually work. They want resumes filled with the latest frameworks, not track records of systems that run without incident. I close the laptop and walk to my window. The Seattle skyline glitters beyond the glass, each light representing businesses built on software someone wrote, debugged, and maintained. Some of those systems are elegant and modern. Others are held together by the digital equivalent of duct tape and determination. But they all have one thing in common. They work because someone, somewhere, understood not just how to write code, but how to write code that survives contact with the real world. I return to my laptop and open Phoenix one more time. Instead of job search listings, I create a new document, System Administration and Maintenance Guide. I begin writing detailed instructions for every aspect of the Meridian Pay system: database maintenance procedures, security update protocols, performance monitoring guidelines, everything someone would need to keep the system running after I'm gone. Not because I'm planning to leave, but because systems in this complexity require institutional knowledge to maintain. Institutional knowledge has a way of walking out the door when the people who built it are no longer valued. The Phoenix repository now contains 847 commits, a complete archaeological record of a system being built, refined, broken, and rebuilt by people who never understood what they were rebuilding. Each commit is timestamped and documented, creating an irrefutable timeline of decisions and consequences. I push the final commit with a message that feels like an epitaph: complete system documentation, everything you need to know. The termination meeting happens on a Tuesday morning, exactly 6 months after Victoria's arrival. HR schedules it as a career development discussion, but the presence of a security escort in the lobby makes the actual agenda clear. Victoria sits across from me in the same conference room where she first called my code amateur work. She's flanked by Jennifer from HR and a security contractor whose badge identifies him as Asset Recovery Specialist. The performance improvement plan sits open on the table between us, annotated with red ink like a failing exam. Maya, we have decided to pursue a different direction for the engineering team. Your contributions to Meridian Pay have been valuable, but we need engineers who can adapt to modern development practices and embrace collaborative team dynamics. She slides a severance agreement across the table. 2 weeks' pay, a non-disclosure agreement, and a promise not to disparage the company in exchange for signing away any claims I might have. Standard corporate burial procedures. We'll need your laptop, access cards, and any company materials, Jennifer adds. Marcus will be taking over maintenance of your projects during the transition period.
Marcus, who couldn't debug his way out of a recursive loop, who thinks error handling is optional and security is paranoia, who's about to inherit responsibility for a $12 million system he spent the last 6 months systematically breaking. I signed the paperwork without reading it carefully. The security escort watches as I pack my few personal items: a coffee mug with a Python logo, a small succulent plant, and a notebook filled with architectural diagrams. My laptop stays behind, along with 4 years of institutional knowledge that exists nowhere else. The walk to the elevator passes in silence. Colleagues I've worked alongside, debugged code with, and solved impossible problems for suddenly find their screens fascinating. The elevator doors close, sealing me off from the system I built and the people who no longer need me to maintain it. At least, they think they don't need me. By the time I reach my apartment, the first automated alerts are already hitting the Meridian Pay monitoring system. Not failures exactly, but warnings. Database connection pool exhaustion during the daily reconciliation process. Memory usage trending upward on the primary application servers. API response times creeping past optimal thresholds. Individual issues that experienced engineers might dismiss as minor fluctuations. But I recognize them as symptoms of a deeper problem. The system is starting to work harder to accomplish the same tasks. Marcus and Dylan's optimizations have introduced inefficiencies that compound under load. I don't receive these alerts anymore, of course. But I know they're happening because I built the monitoring system. I know which metrics correlate with which problems. I know that the current symptoms, if left untreated, will cascade into something much worse within 72 hours. The system I designed included multiple safety nets: graceful degradation under load, automatic scaling of critical components, intelligent retry logic for failed operations.
But those safety nets depend on the error handling that Marcus called over-engineered and the resource monitoring that Dylan dismissed as premature optimization. Wednesday brings the first customer complaints: transaction processing delays during peak hours, API timeouts for high-volume clients. The kind of issues that Meridian Pay hasn't experienced in over 2 years back when the system was still evolving, and I was still learning how it broke. I know about these complaints because they're discussed in the company Slack channels, which I can still access through my phone app, and oversight in the deep provisioning process. I watch the conversations unfold with the detached fascination of someone watching a slow-motion car crash. Marcus posts updates trying to reassure the team, investigating intermittent performance issues, and implementing targeted optimizations. But his solutions reveal a fundamental misunderstanding of the system's architecture. He's treating symptoms instead of addressing root causes, applying band-aids to problems that require surgery. Thursday escalates. The database server crashes during the morning trading rush, triggering the automated failover to the backup system. This should be a seamless transition. I designed it to be transparent to users. But the failover reveals that Dylan's modernization of the database connection handling has introduced a race condition that only manifests during failover scenarios. For 43 minutes, Meridian Pay processes 0 transactions, 0 revenue, angry customers, panicked executives. Emergency bridge calls with engineers who have never seen this type of failure before. The system eventually recovers, but not through any action Marcus or Dylan take. It recovers because the automated healing processes I built detect the race condition and implement a workaround I coded for exactly this scenario, a scenario that had occurred once before, 18 months ago, and which I documented in code comments that were removed as unnecessary verbosity. Friday brings the call I've been expecting, not to my phone, but to my LinkedIn inbox. A message from Jake, the CEO, sent from his personal account rather than through corporate channels. Maya, we need to talk. Can you meet me for coffee this afternoon? Not as an employee, as a consultant. We have a situation. I screenshot the message and save it to Phoenix, then reply with a simple yes and the name of a coffee shop in Fremont, far from the downtown office where I am no longer welcome. Jake arrives 20 minutes late, looking like he hasn't slept in days. His usual startup CEO confidence has been replaced by something I've never seen from him before: vulnerability. He orders a double espresso and sits across from me without preamble. Maya, I need to ask you a question, and I need you to be completely honest. How bad is this going to get? I consider my answer carefully, not because I'm planning revenge, but because the truth is more devastating than any revenge I could devise. Jake, you fired the only person who understood how your system actually works. Marcus and Dylan understand how they think it should work, but they don't understand how it does work.
They've been removing safeguards and optimizations that prevent problems they've never encountered. He nods, rubbing his temples. Victoria says they can fix it, that it's just growing pains from modernizing the code base. Victoria is wrong. And the longer they spend fixing things they don't understand, the worse it's going to get. Jake pulls out his phone and shows me a screenshot of their revenue dashboard. Transaction volumes down 23% since Wednesday. Customer support tickets up 400%. 3 major clients have threatened to leave if the stability issues continue. Our Series B investors are asking questions we can't answer, he says. The board meeting is Monday, and we need to show them that we have this under control. Under control, as if the systematic destruction of a complex system can be controlled by people who don't understand what they're destroying. What would it take to get you back? Jake asks. Not permanently, just long enough to stabilize things while we figure out a long-term solution. I think about Victoria's dismissive smile when she called my work amateur, about Marcus and Dylan's confident assertions that complexity is always wrong, about 6 months of watching competent replaced by confident, of experience dismissed in favor of credentials. It's not about getting me back, I tell Jake. It's about rebuilding trust and expertise. Your new team needs to understand that systems this complex require institutional knowledge,
that the person who built something might actually know more about it than the person with the most impressive resume. Jake nods, but I can see he's calculating costs and timelines, not absorbing the deeper message. If you want my help, it comes with conditions. Full technical authority over the system architecture, no interference from Victoria or her team, and a consulting rate that reflects the fact that I'm being asked to fix problems that didn't exist before I was fired. I name a number that's 3 times my former salary, hourly. Jake doesn't flinch. Done. When can you start? I never stopped understanding your system, Jake. The question is when you'll start listening to the people who do. That weekend, I returned to the office as a consultant, badging in through visitor access while my former colleagues work overtime to fight fires they accidentally set. The irony isn't lost on me. I'm now the expensive outside expert called in to solve problems that my amateur code had prevented for years. The Phoenix repository becomes my roadmap to restoration. Every commit, every documented change, every screenshot of metrics provides a clear path back to stability. Not by reverting all of Marcus and Dylan's changes, some of their ideas were actually good, but by understanding which changes fixed real problems and which changes created new ones. By Monday morning, transaction processing is stable. By Wednesday, performance metrics are back to historical norms. By Friday, the system is handling higher loads than ever before, incorporating the few genuinely useful improvements from the modernization effort while restoring the institutional knowledge that kept everything running. Victoria submits her resignation the following Monday. Marcus and Dylan follow within the week, citing creative differences with the technical direction. They leave behind detailed documentation criticizing the system's return to legacy patterns and warning about unsustainable technical debt. Jake offers me my old position back, along with a promotion to principal engineer and equity that reflects my actual contribution to the company's success. I decline the permanent role, but agree to stay on as a technical consultant, helping to rebuild the engineering culture around understanding rather than just implementing. The Phoenix repository, once a private record of a system's destruction, becomes a case study in the value of institutional knowledge. I presented at engineering conferences with a simple message. The people who build systems are usually the best qualified to maintain them, and expertise shouldn't be dismissed just because it doesn't come with the right buzzwords. 6 months later, Meridian Pay closes their Series B at a $200 million valuation. The system I built, now enhanced but not replaced, processes over $50 million in transactions monthly without a single major incident. The company wins industry awards for reliability and customer satisfaction. I still work from my Capitol Hill apartment most days, consulting for companies that have learned to value expertise over credentials. My rate has doubled again, not because I'm greedy, but because fixing systems is much more expensive than building them right the first time. The Phoenix repository remains online, publicly accessible, a reminder that systems built by people who understand them tend to outlast the people who try to replace them. Each commit tells part of the story, how complexity emerges from solving real problems, how experience translates to better code, and how calling someone's work amateur doesn't make it any less essential. Some foundations aren't meant to be modernized. They're meant to be understood, maintained, and built upon by people who recognize that the best code isn't always the newest code. It's the code that works day after day without anyone having to think about it, until someone calls it amateur work and tries to replace it with something shinier. Then everyone remembers why it was there in the first place. Looking for more? We've got 2 amazing stories ready for you right on screen. If this one touched you, these are absolutely worth your time. Click to watch them now, and hey, subscribe and hit that bell to never miss our latest uploads.